Unit 7. Developments. Recording 18.
Welcome to this introduction to the subject of fibre optics. Fibre optics are an essential part of telecommunications networks. Basically, they are long, thin tubes of very pure glass, arranged in bundles called optical cables. The purpose of fibre optics is to transmit light signals over long distances. Now, I've got a slide here of a fibre optic line, or fibre, as it's sometimes called. In the centre, you have the core. That is the hollow glass tube down which the light travels. The cladding, here, is the reflective material surrounding the core, and this reflects the light back into the core. On the outside, here, you have a buffer coating made of plastic, which protects the fibre optic line. Fibres are very narrow. They can be from 9 microns to 62 microns in diameter. To put this in everyday language, they have the same diameter as a human hair. Transmitters send pulses of non-visible infrared light along the core. What kind of transmitters do we use? Well, laser transmitters are more powerful sources of light than LEDs, but they vary more with ambient changes, or, to put that another way, they are more variable in their performance, depending on factors such as temperature and humidity. Look at the second slide. Here you can see that the light bounces from the cladding that lines the core, and this is called total internal reflection. Think of putting up a lot of mirrors along the sides of a very long corridor. Because the cladding doesn't absorb any light from the core, the light wave can travel great distances. Another way of putting it is that this system allows signals to go round bends and travel a long way. In due course, the light signal degrades. That is to say, it becomes weaker and less pure. This depends on the distance, of course, but also on the purity of the glass. Now, what are the advantages of fibre optics? Previous telecommunication systems used copper wires. These had many disadvantages compared with fibre optics. For a start, the copper lines were very expensive, quite thick, and also heavy. You needed more relay stations than you need for fibre optic systems. In addition, signals through copper wires suffered greater degradation. That is, there was often a loss of signal, and voices on the telephone appeared faint, or else the signal from another line interfered with your signal. This meant that you could often hear another conversation while you were talking. Now, unlike copper wires, fibre optics do not suffer from interference from other fibres in the same cable. Now, I'll hand over to Mona, and she's going to talk about fibre optic relay stations. Mona, over to you.